Hi friends, today we build small Spring Boot application which works with ElasticSearch. What is ElasticSearch? ElasticSearch is a distributed RESTful search and analytics engine which is capable of addressing a growing number of use cases. As part of the Elastic stack, it centrally stores your data for lightning fast search, fine-tuned relevancy and powerful analytics that scale with ease. I propose to generate an empty Spring Boot project with ElasticSearch data dependency, and we will work with it today. So I open my Spring Starter and navigate to Spring Initializer. I call my group, for example, Elastic Example. An artifact, for example, Spring Boot Elastic app. And of course, I select Java 17 for now, Spring Boot version 3, and I add dependency. I need dependency for web because I want to show you results in the form of REST API. I select Lombok dependency and I select Elastic Spring Data ElasticSearch dependency, which will help me to work with ElasticSearch. I generate project and open it with my IDE. Okay, I opened my project in IntelliJ, and first of all, we need to set up ElasticSearch on our local machine. There are a couple of ways to do this. I will use Docker to run ElasticSearch container on my local. You can install ElasticSearch manually on your local machine, or you can use Docker or Docker Compose. And using Docker and Docker Compose, I don't need to install ElasticSearch on my machine. I just need to run container. I create a Docker Compose file in the root of my project and then put configurations to start ElasticSearch engine. So let's do it. Create new file and I call it Docker Compose YAML. And I put ElasticSearch image settings in my Docker Compose. I use ElasticSearch 8.8. I expose ports. This is default ports for ElasticSearch, and I disable security to enable HTTP instead of HTTPS because since I'm working on local, I don't need to worry about this. Okay, and let me run Docker Compose up just to start Elastic container. And while my container is downloading, let's get familiar with Elasticsearch in details. Elasticsearch data in Elasticsearch is stored as documents. You can think about Elasticsearch as like a MongoDB documents. A document is a JSON object that represents a single unit of information, such as product, customer, car, book, or any other entity. Elasticsearch has index. Documents are grouped together within index. An index is like a logical container or a database in which similar documents are stored. And Elasticsearch document has fields. Documents containing fields which represent the specific attributes or properties of the entity which is represented. Each field has a name and of course it has a value. And we will use index and fields in our application, and you will get familiar with it on practice. So my container started. As you can see, I have a bunch of messages, and to check that everything works fine, as I mentioned before, Elasticsearch exposes REST API for your purposes. So I open my browser and I go to localhost 92.0.0, and as you can see, I can see this for search from the Elastic. I can see a cluster name and a lot of other information from the Elasticsearch. For me, it means that it works and it's running on my local machine. So let's get back to our Spring application and create some classes to work with Elastic. First of all, we create model class. And for that, we need package model. I'm gonna store a simple model. I'm gonna store car. Let me create car. Just for the example purposes, I will use small amount of fields. For example, private string ID, private, let me add a private string model of the car. And maybe we can add year of manufacture just to see how integer field works. And let's add, for example, brand of the car. And maybe I want, in this example, I want to show you some nested fields. Let's say a car has owners, and let's create owner model. And I add for owner, for example, name of the owner and, for example, age of the owner. And let's say that car can have a lot of owners. And maybe let's add some Boolean field for owner is active. For example, if this owner is active for now, is active owner of the car. And car can have a lot of owners. And let's generate getters, setters equals hash code and toString using data from Lombok. And we need this one also. And we need to use specific annotations from the Elasticsearch, Spring Boot Elasticsearch, to show that this model will be stored in Elastic. First of all, we need an annotation document. You can think of document as a table annotation for database like Postgres, for relational database. And we specify index name. As I told you previously, documents are grouped together within an index. So we say that index name, for example, let be car index. And inside the car index, we're gonna store car models. We're gonna store ID. We let Spring generate ID for us. And we want to store fields. Field from Elasticsearch. Type of the field is text. So I just use enum text. And I can give custom name to my field using name attribute, for example, like this. And of course, if I need, for example, to use integer field, I change to the integer type, and I can change the name to my custom, and this one. And if I want to use a nested objects in my car model, I need to use a nested type of the field. As you can see, this enum from the Spring Framework Data Elasticsearch annotations has a lot of types for your data, so you can use type for your purposes. And owners. And I need to navigate to owner model, and I don't need to specify index for my owner model because I don't want to store my owner in separate index. I just want it to be stored within my car model. So I just use field type text for name. I can skip name if I want to use this name of my field in my Elastic. and this one, integer and boolean. Something like that. And I'm ready to write my repository. Let me close everything and create new package. And you can think of repository in the same way we work with relational or, for example, MongoDB. You need to create an interface. You need to extend it with proper interface from the Spring, and you will have CRUD operations in your interface from out of the box. Okay, so let me create, for example, car repository, and I extend it with Elasticsearch repository, and I specify car model as my index, and ID type is a string. Okay, and I need to specify interface instead of class. And having this car repository, I already have save, delete, update. I already have a find by ID and other methods which we have for when we use, for example, when we extend GPA repository. So for now, I can use this repository to basically for CRUD operations with my car. And let me show you how it works. In this video, I skip service layer, but this is only for the sake of simplicity and to save some time. Let me create a controller, and we will use our repository inside controller. But if you work on real application, on your own application, and you have enough time, please create service layer and use car repository inside service, and then use service inside controller. And let me create, for example, car controller. It's a REST controller with all args constructor and request mapping as a car. And let's auto-wire our car repository. And first of all, let's create post mapping to store our car. And we want to, I avoid using DTO. I will accept just entities, just models. But of course, as we worked with relational database examples, you can find examples on the channel. Please use DTO instead of entity classes, instead of model classes. And in this tutorial, I will use a model just to save some time and don't use mapping, etc. So let me create accept as car model. And what we're gonna do, we are gonna call car repository and save car. And that's actually how it works with Elasticsearch. As you can see, it doesn't differ for us when we work, for example, with Postgres, because we delegate all the work to the repository, and Spring will automatically create queries for Elasticsearch for you. You just need to call appropriate methods, and that's it. And let me create another method, find by ID, and it's gonna be get mapping, and we're gonna pass ID, and we're gonna return car model, and we're gonna return a car repository find by ID. And as you can see, it returns optional as usual. So you can use get, or you can, for example, throw some exception. Let me just, let me return null if car is not found. And let me create find all. And find all from the car repository returns iterable. You can use streams, for example, to create collection of the car model, but I will return iterable. For our purpose, it's fine. Car repository find all. And next one is delete. And you know what, let's delete by path variable ID. And I guess once we have save, let's create update method. Update, it's the same, but if we pass, for example, car ID, it will update the entity instead of creating it. So we create another mapping, put mapping, and it will be the same as save. I mean, we call a save from the car repository, but if car has ID, it will update it. And for now, let's stop and let's check how it works. As you can see, I haven't added any configurations to my application properties. That's because I use Sprint Starter dependency, and Sprint Starter data ElasticSearch has some predefined configurations. And if you run your application on your local machine, and if your ElasticSearch is running on your local, you don't need to specify any configurations additionally. You run your application and it works fine. If you want to customize your configurations, you need to use Sprint ElasticSearch. And as you can see, there are a bunch of configurations starting from a username and connection timeout, and you can customize URIs. You don't need to create any specific classes with configurations for ElasticSearch. You can use application properties to customize your configurations. And you can check where to. You can check ElasticSearch properties class for customizing your configurations. As you can see, Sprint ElasticSearch is a configuration property, and as you can see, it's predefined. For example, for your URIs, it's predefined for localhost 92, and it's standard host and port for ElasticSearch. So I'm not going to change because my application is running on localhost and on the port 92.0, but of course you can customize this configuration by using application properties and using a Sprint ElasticSearch application property. Okay, let's run our application and see how it works. And let me check. As you can see, it started. Okay, let's open our Postman and see how it works. As you can see, I have already some data. I tested this application before recording this tutorial. So let's start from the beginning. Let's try to find all cars. As you can see, localhost 8080 car, hit send, and you can see nothing is found. As you can see, content is empty because we haven't created any car. So let's create our first car. Let's create a car, for example, BMW model, I don't know, X3, for example. And let's put year of manufacture, and let's put owners, two owners. For example, one owner is not active, but another is active. And let's hit send. As you can see, status is OK. It means that we successfully created our car. Let's send, hit say find all, and you can, as you can see, we successfully found our car in the database. As you can see, ID is generated for us, and you can use, for example, find by ID to find our car by ID. And as we send a request, we receive a response. And of course, you can create a bunch of cars. For example, Bill, and let it be false. This one is true, for example. Hit send, and once I hit send multiple times, I can see that I created a bunch of cars, and I can use, for example, put mapping to update my car. Instead of, as you can see in post, I don't use ID, but for example, if I want to update this car, let me copy and put, and I need to put ID. Let me find some car which I want to update. For example, this one. No, let's update this one. And I want to set it for example, ABC. And I hit send. As you can see, status is OK. Let me find this car by ID and check how it works. Hit send. Sorry, should be some. I guess I copy pasted. Should be some data. Yeah, I just copy pasted part of ID. As you can see, we have updated car. Let's delete this car by ID, for example, using delete mapping, and click send. As you can see, status is OK, and if we get by ID, we won't find this car in this in our Elasticsearch. And actually, that's how you can use your Elasticsearch configurations. As you can see, no configurations at all in my application properties, and I have shown you how to customize it. But what if you want to create some additional methods, not only CRUD method? You can always use car repository to define your custom methods. For example, let's say I want to find all cars by brand. I just create a method, my custom method, find all by brand, for example, and I pass brand, and Spring automatically transform this method to the query for the Elasticsearch, and it will return me results by brand. You can always use your query, your custom query, for example, using this query annotation, and you can pass your text query, the same query as you pass to Elasticsearch. It's also possible, and it will work. And you know what, let me show you how this one works. Find all by brand. Let me create controller and public list car model. and I return car repository find by brand, and I restart my application. Yeah, I need to add path. Something like that. Or let me show it, let me rename it to find, just to stick with the REST naming convention. Okay, let me open my Postman. You know what, let me copy paste this, and we put find, and we put brand, and what brand do we have? Let me check. We have BMW. We click send. As you can see, we receive all data using brand BMW. For example, if we want to store Tesla, and I don't know why, and let's put Tesla. We click send and we receive data for our Tesla brand. Actually, that's it. This is a short intro to the Elasticsearch and Spring Boot. As you can see, it's easy to start working with Elasticsearch using Spring Boot dependencies, because all the hard work Spring does for you in this car repository. All you need just to create your repository, extend it from the Elasticsearch repository, and that's it, and you can use your queries. Thanks for watching this video. Don't forget to subscribe to the channel, and I see you in the next video. Goodbye.